Okay, 7th graders, we're talking about finding unknown measures in similar figures. And our essential question is, what information do you need to know to find the dimensions of a figure that is similar to another figure? So here we're told that the two triangles are similar. So they're telling us that information. And we need to find the value of x. You'll probably remember, I can't remember if you did this in 6th grade or not, but anyhow, we've been solving proportions a lot. So here, what I always tell my students is same figure, same fraction. So I would write this fraction as 6/8. And then our proportion, you can see that 6 and 9 are corresponding sides. They go together. So because they go together, the 9 has to be across from the 6. And then we can find our x value by doing 9 times 8 divided by 6, and we get 12 meters. So it's just solving proportions. Our next problem, the two quadrilaterals are similar. The ratio of their perimeters is 12:5. Find the value of x. So if we know that their perimeters ratio is 12:5, we also know that their side length ratio is 12:5. And the 15 is the bigger, so it has to go with the 12. And the 5 is going to go with the x, so we do 15 times 5 divided by 12, and we get 6.25 inches. On the next one, the two quadrilaterals are similar. The ratio of the perimeters is 3:4. Find the value of x. Well, we can see that the bigger of the two figures is 12, so the 12 has to go with the 4. And 4 times 3 is 12, and 3 times 3 is 9, so x equals 9 feet. Okay, turn your paper over. Indirect measurement uses similar figures to find a missing measure that is difficult to find directly. So indirect measurement uses things that are easy to use to find the missing measurement of things that are hard to find, or hard to measure. A person that is 6 feet tall is here, and they cast a shadow that's 3 feet long. So there's their shadow. A nearby palm tree casts a 15-foot long shadow, and it's easy to measure the shadow because that's on the ground, but if we're trying to figure out how tall the palm tree is, that would be much more difficult to measure. So what is the height h of the palm tree? Well, I know that the person is 6 feet tall and their shadow, so the actual measurement is 6 feet, their shadow is 3 feet. And I know the shadow measurement of the palm tree is 15. And 3 times 5 is 15, so 6 times 5 would be 30 feet tall. That's the palm tree. Now we have a problem that says, what if later in the day the palm tree casts a 25-foot long shadow? So how long is the shadow of the person now? So now we know on the palm tree that the shadow is 25, and up here we found that the actual height was 30. So now we have to use 30 and 25 for the actual and the shadow. And we know that the person hasn't changed. They're still 6 feet tall, but now their shadow would be 6 times 25 divided by 30, which is 5. So now their shadow is 5 feet instead of 3 feet. A swimming pool is similar in shape to a volleyball court. What is the area A of the pool? All right. So if the swimming pool is similar, they're similar, and the ratio of the pool to the volleyball court is 18 to 10. This is the pool, and this is volleyball. So the ratio is 18 to 10. Now, we have to figure out the ratio of the areas. And this is just the ratio of the sides. So the ratio of the areas would be the sides squared. So 18 squared, or 18 times 18, is 324. And 10 squared is 100. So the ratios for the area is 324 over 100. Again, because to find the area ratio, we just square the side ratio. And now we know that the area of the volleyball court is 200 yards. So times 2 will give us that answer. So 648 yards squared would be the area of the pool. And our last question, the length of the volleyball court is 20 yards. What is the perimeter of the pool? Alright, so if I know that the length of the volleyball court is 20 yards, the length of the pool would have to be 36 yards. And the perimeter then of the pool is 36 plus 36 plus 18 plus 18, and that gives us 108 yards for the perimeter. Have a great night.